Hello everyone, let's look at this integral today. We have ln of x raised to the second power, and we did the integral of ln of x last time, and then we have the result. The antiderivative of natural log of x is x times ln of x minus x. And so when we integrate this one, we probably will need to use the result that we obtained last time for the natural log function. Okay, so let's look at this. We can do it using integration by parts. I'm going to do it the traditional method, and then in another video, I'm going to use the tabular method to show the comparison. Okay, so first we are going to set up the UV and then du dv table, and then we choose our u, right? So let's do that. Okay. So here we are going to just say that we are going to just let u be ln of x raised to the second power. In other words, we are letting u be the whole function right here. And then you may say, what is the dv? The dv would just be the 1, just like how we integrated the ln of x last time. So we are going to let dv be 1. And then, of course, there was a dx there, but that really doesn't matter, right? We know that there is always a dx that we are going to put here. Okay, so now we are going to differentiate this u, which is this function right here, and we gotta use the power rule first, and then we also need to apply the chain rule at the same time, right? So we are going to bring down the 2 in the front, right, when we find the du. So we have 2, and then bring down the power, and then we substitute the inner function in there, and so now the exponent becomes a 1 for the ln of x. And then we need to do the chain rule, right? We need to multiply by the derivative of the inside function, which is 1 over x. So we put 1 over x right here, so times 1 over x, and then dx. Okay, so what about the v? The v is easy. The v is actually just x. The dv in this expression right here is too close to each other, so let me move a little bit of that so that it won't cause any confusion. Okay, now that's good. Okay, so we are going to now start writing down the results from the integration by parts. So using the integration by parts formula here, we have u times u, right? So uv, and then that's x times ln of x raised to the second power. So let's just put that here. At the same time, I'm going to clean up the expression, so you can see that I will put the x in front of the u. So we are in front of the ln of x raised to the second power. So we will have x and then ln of x quantity raised to the second power. Okay, so that's our uv. The next step is to write down the integral of v to u, right, with the minus sign in the front. So we put the minus sign, and then now the integral. This one, I try not to clean up the expression while I'm substituting the expressions in there. So just leave it for now, and then we'll clean up the expression in the next step. Okay, so we have the integral, and then the v is just dx, so we put the x here. And then times. Now, what is the du? The du is all this stuff right here, so it will be 2 ln x times 1 over x dx. So let's just put that here. So we have 2, and then ln x, and then times 1 over x, and then the dx. So this looks like a messy expression, but actually is not too bad. You can see that we have a x here, we have a 1 over x here. You can cancel them right now. You can reduce the fraction, so we can cancel them. Okay, so we don't need to worry about it anymore. And so in the next step, we are going to just clean up our expression. So we are going to get x and then quantity of ln x, and then raise that to the second power, and then we have minus. Now there is a 2 here. That's a constant, right? We can move it outside the integral. So we have 2 times the integral. And then because the x and the 1 over x are cancel out, so we only have the natural log of x right here. So we have natural log of x and then dx. Okay, so what do we do next? If you look at this integral here, we just need to find the antiderivative of natural log of x. if you do not memorize this result right here, we have to do what we you actually will have to do integration by parts one more time by letting u be ln of x and then letting dv be 1, and then you follow the same process as what we did right here, and then you can figure out the antiderivative of natural log of x. But we did it in another video, so if you are interested in seeing the steps for finding the integral of finding this integral, then you can click on that link in the description. But right now we are just going to use the result that we obtained from last time. So we are going to get x ln of x minus x, right? So that's our antiderivative. So our next step would be x times ln of x and then square, and then now minus 2. Okay, so one thing that's really important here is that when you put down the minus 2 and then when you copy the result from here, is that you need to remember that the 2 or the negative 2 must be distributed to all the terms that we have in here, right? So make sure that you put parentheses because there was more than one term here, so you would need to put parentheses. Otherwise, the 2 will not be applied to any terms um, that's not part of the x, ln x. So that will cause the error. So make sure that you put parentheses. So we have, I can put a pair of brackets right here. So we have x ln x and then minus dx. So now you can distribute the x, I mean the 2 in there. So we have x times ln of x and then square and then minus 2x ln of x. And then you can have what? Negative 2 times negative x, right? So we get positive 2x. And then at the end, we can put down the constant of integration. And so that's our final answer. Okay, so in the next video, we are going to do the same integral, but we are going to use the tabular method and show what's going on. Okay, so thank you for watching. See you next time.